All right, so in the first video, we looked at whether there was an association between how many siblings you have and what age you were diagnosed with asthma. And looking at the picture, meh, the best fit line was just kind of going straight across and didn't really show any pattern in these dots. And the p-value also was way too big, 0.621. So what I've done is I have gone back and picked two quantitative variables that I knew were going to be associated, height and weight. And so what I did is I made a variable height out of inches and feet that are what are in the code book. And so, for example, I'm 6'4". So if I had filled out this survey, I would have said my H4GH5F is 6 because that's how many feet. And then the I would be 4 because that's how many inches, 6'4". And so when I multiply the feet times 12, I get how many inches are there, and then add the rest of my inches. And for me, I get 72 plus 4 is 76. So I'm 76 inches tall. I did the data management for that. These are the only numbers that came out that weren't real and were coming from things like not going to tell you or I don't know. And then I did the same thing for weight. Weight is weight in pounds, and so I don't need to do a formula, but I did some data management. 996 and 98, data managed those out. And then these were weights that I knew were typos. 18 pounds, 20 pounds, 22 pounds. These are not adults. That was a typo, so I data managed it out. When I looked at the scatter plot, looks pretty good, right? So yes, it's sort of a blob of dots because there's people that are above this line and below this line, but I can see the trend that the taller you are, the heavier you are. The problem with it right now is that this is everybody, and the weight-height relationship is different for women than it is for men. And so what I did is I went back and I said, okay, I'm going to make a new data frame called males, which is where I take the whole data set and group by this gender variable. Biosex 4 has a 1 for the men and a 2 for the women. And so I made this whole new data frame where it's just the men in males and just the women in females. Then what I did is I cut it down to only have height and weight, the variables that I created up here, and where I dropped the nans. And so CDM has just height and weight for the males, and CDF has height and weight for the females. All right, so then if I look at the scatter plot now with my data frame being just the males, I get a slightly different picture and notice that the minimum height is 60 inches or 5 feet, whereas before you had some women that were under 5 feet, right? And so it's a slightly different scatter plot. And then when I run my correlation model and see what my p-value is, this is what I get. I get a huge test statistic and a p-value of 5.18 e negative 78. If I went back and did this with CD, did not mean to do that, sorry. If I do this with CDF instead of CDM, I get a slightly different scatter plot, right? Now I have the women down here, and I don't go all the way to 80 of an height. And then I just have to put CDF over here and CDF over here. And then I do run the correlation, and I get a p-value that's small enough again. So I'm going to go back to the men because I'm a man, and I want to do this for my data. And so I'm going to go back and go back and go back. There we go. So I didn't run this when I went back. There we go. There's the scatter plot for the men and the scatter and the test, the hypothesis test for the men, the Pearson Correlation hypothesis test. Okay, so I have a p-value that's less than 0.05, so I have significance. There is enough evidence to suggest that height correlates with weight, or that height and weight are associated. Okay, and I have my M and my B. So with those two constants, I can get my regression model that tells me, okay, so weight is my y variable, right? Okay, so weight is my y variable. So this formula is basically the y equals mx plus b with the y variable weight, the x variable height, and then this value for m that I see right next to height in this output, and then the value for b. So when I plug in my particular height, 76 inches, what it tells me is that I'm predicted by this model, I'm predicted based on my height to have a weight of 230, almost 232 pounds. Now that's not what I weigh. So I can calculate the error in that prediction because I have an actual weight that goes with my actual height. And so what I do is I put the predicted value right here, subtract off the observed value, what I actually weigh, and then it says that the model overestimates my weight by about 40 pounds. So all of this stuff I want on your slide. And if you're not comfortable putting your own height and weight in here, then you got a couple of options. You can go to your scatter plot. You know, if you're a man, you're looking at this scatter plot. If you're a woman, then you change to F on all of these, right? You can pick one of these dots and then estimate what the weight and height are and then plug that in and figure out the error. Or you can pick a friend, or you can make up a height and a weight, but I want you to go through this activity of figuring out, based on a particular height, what weight is predicted by this model that we see graphed right there, and then figure out what the error is. Okay, I hope if you have any questions, you are asking me. But otherwise, I will see you in class.